The ROG Ally is one of the best handheld consoles on the market, but it does have a couple recurring issues that people tend to run into. One of those being a lack of power to the board. It looks like this is a charge controller failure. There's a little MOSFET on the board that just goes bad because this thing gets hot and it tends to cook, like absolutely cook all the components on the board eventually. First, you'll notice your SD card will go, and then your charging controller will go. But there's a little bypass for this. As long as you aren't afraid of some soldering, let me show you what to take a look for. So part of my troubleshooting for this issue on the device was tearing it down to figure out what the hell was wrong with it. And I mean, like, I have absolutely gutted this thing. In theory, now that I know how to fix the issue, you could leave this board in the chassis, but it involves some soldering up in this corner here, and it's quite fiddly, so I really wouldn't recommend leaving the board in, just because it's kind of right above the screen and some other controls that we really don't want to mess with. So it's best to remove this board completely. It's a couple screws, it's not a big issue. So when we're looking at the board here, just to give you some reference points, this is our charging and docking port up here, micro SD card reader, headphone jack. And this region of the board is really dedicated to power delivery and charging. The issue we're running into is with the little MOSFET that runs the handshake between the device and your charging brick or charging adapter. And it's right in here. Let me zoom in and show you. Okay, so the board is in the same orientation it was before. If you remember this little loop of wire from the last shot, you'll know where we are. But just for reference, here's the little FFC connector that goes to the little thumbstick subassembly on this side. And if we go over to the left here, behind my wire that I've added here, there's a little charging chip. It's gonna say, if you look at it with a little magnifier, you'll see that it says LG on it with a number of letters after that. The LG is just ASUS's naming convention for this chip. It's not necessarily, made by LG or whatever, but that's the little chip that controls the charging circuitry and that handshake between your device and the wall. What you're gonna wanna do to bypass this issue, and this is easy to test while the chassis is still, or while the main board is still in the chassis, if you short out this side of this resistor to the far side of this middle resistor on the right hand side of the chip, closer to that FFC connection, you should, if this is the issue on your device as to why it's not powering on or charging, you should immediately see the charge light come on. What I did to test for this is I just have a little pair of tweezers. You can just carefully go in on either side of that chip or on either side of those resistors, quickly bridge them while it's connected to power, and you'll immediately see that charge light go on. If that charge light goes on, that means this little chip here is your issue. Unfortunately, unless you are excellent at microsoldering, this isn't going to be an issue that you can fix by just swapping out the chip. It's a surface mount. All the pads are on the underside. When you look at it, it's a little deceptive. You might see those tiny little solder pads next to the chip. Those little ones right in here. There's 4 on each side. Those aren't actually where the pins connect. They do connect underneath. So unless you are equipped to microsolder, don't try it. Just don't try it. And to make this a little easier to talk about, we're going to go big Clive style and draw out a little diagram here. Essentially, this is the little chip we were talking about, the LG. And you're going to want to bridge from the top of this resistor down to the bottom of this resistor. And this is looking at it, in reference to the board in this direction, the same one we were looking at in the last shot. So you just bridge from there to there. If the light turns back on, you know that this chip is your issue. If you bridge this connection and the light doesn't turn back on, chances are you have a short somewhere else on the board, and this won't fix it. But if it does, work, that's great. One trick for soldering onto these little resistors is when you look at the board, you'll see the little solder pads on the bottom. You're going to be tempted to try and get really, 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 really precise. You're going to want to try to tap your wire in there. And tap your wire in there. However, these little resistors are handy. They have a solder pad that goes all the way up the side and just around the top ever so slightly. Same on this one. So this actually makes it a lot simpler of a solder job. So you can go in, and if you whittle down, I just quickly ground a new little tip into the end of my soldering iron, so I have some precision. Micro soldering adjacent size, fingernail for context, right? And you can go in and you can just add the tiniest little bead on top of the ends of those resistors where you're going to add a little chunk of wire. For this, I just used, I had a little chunk of wire left over from a fan from a computer build I did a while ago, just a little 5-volt fan. The wire might be a touch thick for this purpose, but I did try going thinner and using a little strand of wire from actually that same computer fan's motor coils, and it didn't work. Whether it was plastic coated or something and I just didn't notice, I don't know, but I think it was just too thin of a gauge of wire. So you really do need some kind of resistance here. So you just bridge up from this connection over to the end and just pre-tin your wire, do a quick boop, boop, hit it with some heat, and it'll work just fine. Obviously unplug it while you're soldering, but once you plug the board back in when you're done, the light should come back on. And just one last thing to keep in mind when you're doing this kind of repair. There are a lot of other components in this chassis, and the tolerances are quite tight. So if you're doing a little loop of wire here, this is as small as I could reasonably manage. As you can see, I shake a little bit. But you just want to make sure that it's folded down nice and tight to the board and obviously well insulated, just so it doesn't short out on anything or cause some unnecessary pinches or issues there. The only other thing to mention would be do this at your own risk. We are obviously bypassing what is essentially a safety measure here. That little charging chip can be considered a safety measure. So if you are doing this, I would say blanket statement across the board. Use this more like a desktop console. Use it in a dock, hooked up to power, and disconnect the battery completely. Just don't hook that back up. Use it on wall power. But if you absolutely want to continue using it as a handheld, just be cautious. Wherever you can find in the settings to adjust, software limitations on how far the battery can charge, I would highly recommend that. You're piping, I believe it's 12 volts or 12 or 20, something like that, out of your charger by bypassing this chip. And frankly, it's a fire risk. So do so at your own risk. And just make sure that if you are, putting the battery back in, use software to prevent it from charging to 100%. The unit will still be able to shut off the charging with this bypass involved. It just automatically defaults now to the higher voltage and higher wattage. Anyways, hope this all helped. Good luck with your Ally. It's a fun console. Just little things like this really grind my gears.